Welcome to Next Gen Manufacturing. You know, when you see a massive humming factory, whether it's a chemical plant or one of the new Gigafactories, there's always a secret behind it. And it's not some new gadget or a rock star engineer. Nope, it's a document, a master blueprint that is literally the difference between wild success and catastrophic failure. Today, we're going to unlock that secret. Okay, so picture this. You've got an international team building a huge new chemical plant. You've got the contractor, the company with the secret recipe, a top-notch engineering firm. Everybody's excited. But then, things start to go off the rails. Change requests start piling up, arguments break out over who's supposed to do what. One account of a real project just like this said, the greatest confusion took hold. Engineering hours nearly doubled. An absolute disaster. So what on earth went wrong? I mean, this wasn't a team of rookies. These were all experts, the best in their fields. But they were operating with a fatal flaw. They were missing one single critical piece of the puzzle that turned this amazing project into a black hole for time and money. To figure this out, we got to rewind to the beginning. So in this real-world case, the company with the process, let's call them the knowers, they didn't really have the time or people to create a formal, detailed blueprint. So instead, they just handed the engineering firm, the builders, a bunch of old plans from a smaller factory and said, "Don't worry, our experts will pop in and help you out." And that little handshake deal, that was the project's original sin. Without one single source of truth, every single decision became a fight. So here's the thing. The problem wasn't a lack of talent. It was a total breakdown in communication. There was a missing link. All that essential knowledge, the real why behind how the process worked, it was never properly transferred from the knower to the builder. It's like they were trying to build a skyscraper, but the architect just kind of waved his hands and said, "You'll figure it out." It created total, complete ambiguity. So what was this missing link? What could have saved the whole project? Well, it all comes down to a concept called basic engineering. And listen, this isn't just a simple set of plans. It's the formal, super detailed handover of all the critical knowledge needed to get the job done right. And this definition right here, this really nails it. Basic engineering is the whole shebang. It's the complete knowledge package. It spells out everything about the core process. It's tailored to the specific building site, all so that a skilled builder can just take it and run with it all the way to completion. It really is the bridge that takes you from a brilliant idea to a working factory. Now, this is maybe the most important distinction to understand. Basic engineering is all about the what. It's the secret sauce, right? The core recipe. It defines the essential technology. Detail engineering, that comes later. That's the how. That's the step-by-step instruction manual for actually building the thing. The specific pipes, the steel beams, all the nuts and bolts. You absolutely cannot get the how right if the what is a fuzzy mess. All right, so what's actually in one of these master blueprints? This engineering Bible, as some people call it. Let's crack it open and take a look at what makes it so powerful. A real basic engineering package leaves absolutely nothing to chance. It starts with the basics, the raw materials, the site conditions, all of that. Then it dives deep, mapping out every single flow, specifying every critical piece of equipment, and even planning the general layout of the whole factory. It even includes the instruction manuals for how to run the plant after it's built. It literally defines the entire project before a single piece of steel is even ordered. But here's something that's kind of wild. The size of these blueprints, it varies a lot. For a really simple project between two companies that trust each other, it might be just a few pages of sketches. But for a super complex, high-stakes international project, it can be, and I am quoting here, trunks full of documents, canteen-sized, stuffed with carefully indexed volumes. Can you imagine that? Okay, so this isn't just some technical paperwork, right? This is a massive business deal. This document, this blueprint, it's a product that can be worth millions of dollars. And the moment it gets handed over is a huge strategic moment. So just how big of a deal is this phase? Get this. Creating the basic engineering package can take up 20 to 30% of the total engineering hours for the entire project. That's a huge upfront investment. But you know what? It's the price you pay for clarity. And it's the only real way to prevent that expensive chaos we talked about from ever happening. And that value is exactly why this whole process is so important. The basic engineering package is the main way technology gets transferred all around the world. See, countries that want to build up their own industries, they don't just buy a finished factory from someone else. They buy the license and the blueprint. This lets them use their own local engineering and construction firms to build it, which helps grow their own economy and expertise. Pretty smart. Of course, because these blueprints are so incredibly valuable, they can also be used for some pretty clever industrial espionage. There's this one incredible story where a client was getting bids from two firms. They told firm A, which had this superior American technology, hey, you got the job. But they said, first you have to sign this side deal with the American tech owner to get the license and the basic engineering package. So they did. And as soon as they had that super detailed blueprint in their hands, they cut off all communication with firm A and gave the final construction contract to firm B. The result? They got their factory built and they walked away with a trunk full of their competitors' most valuable trade secrets. Wow. So all of this history brings us to the big question for us here at Next Gen Manufacturing. This idea of a paper blueprint might sound a little old-fashioned, but the principle behind it, it's actually more important than ever as we start designing the incredibly complex factories of the future. Because at the end of the day, the fundamental challenge never changes. It doesn't matter if you were building a chemical plant in the 70s, a lithium-ion gigafactory today, or a quantum computing lab tomorrow. You still have to solve the exact same problem. How do you take a brilliant idea for a process and turn it into a real, working, physical factory? You need that master blueprint.
And that leaves us with a final thought, a really big one to chew on. As our factories become more intelligent, as they get connected to networks, as they start self-optimizing with AI, as they become these living systems of data, what will their master blueprint even look like? Will it still be a static document, or will it be something more like a dynamic, always evolving digital twin? Now that's the question that the designers of tomorrow's factories have to answer.